What's up, Pakacha? It's Kedale here, and we will be continuing where we left off in our unit operations lesson, particularly in the evaporation. Okay, so I hope you prepare yourself for these problems because they are really hard. Okay, so yeah, let's move on. So we're now here at our this is where we left off. Number 15. Okay, now let's move on to number 16. This is somewhat hard. Okay, so please read the problem. I will be speeding through here. So we have number 16. Okay, let's draw everything. We have F here, 200. Then we have okay, 100 na siya. And then you have condenser now. You have a condenser. So this condenser has entering water temperature of 70 degrees Fahrenheit, and then the water now is 100 gallons per minute, diba? And then you have exit water temperature. And then this condenser is operating at, diba? So you have your V here. So this is operating at 100 at PC sa una. Okay, PC. Okay, at the pressure 26 inches nga mercury, diba? inHg nga vacuum. Okay, ba? Vacuum? Think vacuum? Vacuum pressure or no. Vacuum pressure. The vacuum pressure of the barometric condenser. Okay, diba? So you know how to get that. So 29.92. This is the inHg barometric pressure in inches mercury minus 26. Diba? You have 3.92 inches mercury. Transform that to pascals dayon so that you can easily get it from the steam table. Okay, so if you transform this to kPa, you have 13.28 kPa. Okay, so don't forget to subtract it first from 29.92, so that you will get 3.92, and then 3.92 you can transform that to 13.28 kPa. So that can get temperature 51.1 degrees Celsius or close to 124 degrees Fahrenheit. Okay, so let's see our S here. Then we have XF.1, and the temperature of the feed is 80 degrees Fahrenheit. You have your steam at 34.7 psia, 20 psig naman to, so let's add 14.7 so that you can get the psia equivalent, or this is 239 MPa, diba? Temperature of this steam is 258.5 degrees Fahrenheit. Okay, you get then the XL is equal to 0.40. Yeah. So to make this easier, let's tabulate everything. Okay, so we have our stream. Okay, stream, and then the flow rate. We have the temperature. We have the latent heat, diba? Or the enthalpy, no, not latency. So this is in BTU per LBM. Yeah. And then also the small h. Okay, same with the unit. You have your feed, you have your thick liquor, your vapor, and then your steam. Diba? We don't know the flow rates. We know the temperatures. 124, 124. Then we have 258, 258.5. Okay, so we don't have the vapor enthalpy for them. Just that. Yeah. How do you get this from the steam table? Diba? Steam table is in kilojoules per mole. Diba? So whatever you get from there, just multiply it by 23.8592. Okay, just multiply it by that value so that you can get these values. 1114.52 BTU per LBM na siya. And also this is 1665. Okay, these are from the steam table ng mga values. Okay, so you have HF, we don't know, we have no data for HF yet, but we can get it from figure HF. So HF get from figure 2-29. Okay, you have the during lines there, so just project it from to the up in 80 degrees Fahrenheit and project it to the left. You can get your enthalpy na dayon equal to 45. So 45 siya. BTU per LBM hapon. And then from the steam table, you can run siya 91.69. Yeah. And then this is also from the steam table, 227.21. Okay, so we now have to solve na, diba? But we have to account for boiling point rise. Okay, so this is the time that we have to account for boiling point rise. So remember that our operating temperature is 124 degrees Fahrenheit. Diba? So how do we get the boiling point rise of that? So simple. You can get it from the figure 11.129. Okay, so you get there from in the so diba diha na 120 na 130. Okay, so the conha then i-project din ninyo dito siya dito sa to the left. Okay, so you have the point of NaO there, and then mark it. So na the leftmost, diba? Leftmost line, and then you have another line here that says the weight percent. Okay, so find 40% here. Find 40% here, and then project it back to here, and then you can get the boiling point rise here in this side, and then read it from there. I got 43 degrees Fahrenheit. Okay, as my boiling point rise. Yeah, so now we will have to find we don't know, diba? We don't know our feed rate, we don't know our steam, we don't know the L, we don't know the V, diba? But we know the water, diba? The GPM, the 100 gallons per minute. How can we use that to our advantage so that we can get the V, diba? Or the vapor was produced. Okay, so it's really simple, diba? So it should be at at condenser. So HB at condenser. So we have a QV is equal to negative Q, which is the cooling water, diba? And the cooling water is equal to WCP TW1 minus TW2, or bali, TW1, okay, TW2 minus TW1. Okay, so transform, we have to get that heat of our cooling water, diba? We have 100 gal per minute. Transform that to mass flow rate by using the density. Using the density, you have this is cubic feet, and then 7.481 gallons. Diba? The density at that temperature, it is obtained at 85 degrees Fahrenheit, which is the average of 170. Check that. This is 170 divided by 2 is 85. It's 62.165 pounds per cubic foot. Then you will get just multiply na. Diba, CP is 1, and then 100 minus 70 is 30. Yeah, you can get 24,929 BTU per minute. Okay, so how do you get our V now? So you can get your V, diba? We have this, HB, HL plus V, CP of the vapor times the vapor temperature minus the feed. Okay, so that's how you do that. And then isolate V to the left side, and then you can get everything here. So QV, then HB, HL plus CPV, PV minus TF. Okay, so substitute everything. So you have 24,929.15. Then you will have here at the bottom denominator 114.52 minus 921.69 plus 1, 124 minus 100. Okay, so this is the temperature of the vapor, diba? As it goes outside the evaporator, and then the final temperature of the water, which is 100 degrees Celsius. Okay, so you have 23.814 BTU LB per min. Okay, so you now have the value for the V, so we can proceed to the overall mass balance. Okay, overall mass balance. So this is F minus L is equal to 23.814. Diba? You have your CMB is equal to 10 minus 0.4, then L 0, F is equal to 31.752 pounds per minute, and then you have your thick liquor L 7.38 pounds per minute. Okay, Then we will have to find the we are now going to the overall energy balance, okay? But take account, diba, for the BPR, diba? So accounting for BPR, so the new our HV now, diba? This is just really simple. Don't panic if you get BPR, diba? So we have 0.45. This is the multiplier or the CP, okay, of the steam, diba, in BTU per LBM. So just multiply that by the boiling point price we got earlier, diba? So natin kay 1,133.87 BTU per LBM. So now we have HL also. Diba HL, we don't have the value for HL yet, but we can get this from figure 2. Ito yun natin, figure 2-29 during lines. Okay, this is 150 BTU per LBM. So what temperatures did I use? The same, about 124 degrees Fahrenheit. Okay, nga temperature para makuha ang 150 BTU per LBM nako na enthalpy. Okay, so now we'll go to our energy balance, diba? Energy balance, okay? Our energy balance, FHF plus S, okay? So this is gamay nga S, okay? And V, HV plus L, HL, okay? Take note that we will use these values na. Okay. So 31.752 times 45 plus S. Input the values of HS and HS here. Kini mga values, kini siya. And then substitute everything. Okay, you will get your S to be 28.489 pounds per minute, or transform that to hours. So you have 1709.35 pounds per hour. Okay, and then you can get the area, diba? So 1709.35, ito minus niya po, and ito siya HS minus HS, then you have a 200 here, then 258.5 minus 167. Okay, so 167 is just 124 plus 43. Okay, so we took account for of the boiling point price here. You can get 87.8 square feet, or the nearest in our answer is 91. Okay, so it's really long, but please, I hope you got that. Okay, so now let's move on to number 17. So let me just clear all it here. So number 17, it's quite easy for number 17. Okay, number 17 is quite easy. So just triple effect evaporator. Okay, so we have U1 is equal to 150, U2 is equal to 200, U3 is equal to 250, 200 and 250. Okay, we are asked for the area of the first effect in square feet, or the steam is used sa 10,000 pounds per hour. Okay, this is easy, guys. Really easy. Okay, all you have to do is to get this. Okay, so the delta T overall, diba? I've shown you this kanina. V3, or the last effect, temperature of the last effect, minus the sum of the BPRs. Okay, but we don't have this, diba? So we don't have that. So you only have your 250 na temperature sa steam minus the temperature of we have this thing, we have that 150 minus 55 na BPR, diba? So you have 45 degrees Fahrenheit. So how can you get, diba, T1? Okay, so this is the overall man, overall. So how can you get T1 so that you can get remember, our goal is to find this, diba? So and we are on the first effect man, so we can use the steam because of the first effect, diba? We can use the steam, so U and T1. Okay, so we know the amount of steam, which is 10,000. Okay, so but we don't know the 1. So how do we solve for 1 at delta T1? Okay, so you have this formula. So 1 over U1, 1 over U2, 1 over U3. Okay, so just substitute all given there. Okay, U1 150, U2 200, so you will get now 19.149 degrees Fahrenheit na delta T1. So substitute that here. Don't forget to get the value of H and HS there, ha? So this is found in Paris. Okay, so I'm not gonna there. So this is what I got from Paris, 3.648 minus 218.316. Okay, so we have your U1. This is U1, huh? This is 150, no? 150 times 19.149. We will get 3291 square feet, or close to 3,300, which is letter B. Yeah. So that's number 17. Okay, let's move on to number 18. So solution to be evaporated tends to strongly scale or form salt. Type of evaporator to be recommended is, so you have to read this from Paris. So this is found on page 11-112. Okay, the answer to this is letter C. And then number 19, you have to use also you have to use figure 11-124. Okay, so you can get this and start from you might ask me what temperature you have to start, diba? Temperature of the water at boiling temperature, which is at 212 degrees Fahrenheit. So start there and project it to the left, and then project it to where 30% weight there. So you can get number 19 as letter A. So it's close to 20. I got 18, siguro 18, but it's close to 20. Yeah. Oh, number 20. Okay, number 20 is the same. Okay, it's the same as number 17, although a bit complicated, diba? But you can see this. It's really easy. Number 20. Okay, number 20. Number 20 is you have this T, TS, TE, and then the BPR, diba? BPR. So just add these BPRs hapon. BPRs, you have 38. Now have 38. So temperature of the steam is 250 minus 120 minus 10 minus 28. You will get 92 degrees Fahrenheit, diba? So you have 92 here, and then 1 over 300, 1 over 300 plus 1 over 250. Okay, so you'll get 41.8 degrees Fahrenheit. So you can round it up to 42. T2, do the same thing. You can get, but this time 1 over 250 na. Because we are going to for U2 na. 300 and 250. Okay, so you have 50.2 degrees Fahrenheit or 50 degrees Fahrenheit. So how do you solve this? How do you get that boiling point of the solution in the first effect? Okay, how do you get that? It's really simple. You have to do, this is what I have got in McCabe. Okay, so you have that temperature profile, so divide that to sections. Okay, so you have to start with the temperature of the steam, which is 250. 250. So at the start of the 250, okay, so you have your 42. 42 nga kuan, 42 T1. So 250 minus 42 is 208. Okay, so now get the next, which is 10. 10, which is the boiling point price of the first. Okay, so this is 198. Okay. Next is 50. 50, T2. Now you will get 148. And then the last boiling point price, which is 28, just subtract it from there and you will get 120 degrees Fahrenheit, which is the temperature of the second effect. Okay, so that's how you solve that. Then you'll get the first effect is 208 Fahrenheit. Okay, so I will cut here. Okay, so the last 5 problems are still very difficult. They are problems in their own right. So I will make it a 3-part video. So please forgive me because it really takes very long time for it to finish. So I will just cut here. Please still watch out for part 3. Okay, so but if you haven't subscribed yet, please subscribe to my channel. We have 122 subscribers, and please, if you really support this channel, please share it to your friends. Okay, so that ends this part 2 of the video. I have a goal to just keep it under 30 minutes or just under 35 minutes, so that the viewer will not be dili kay siya taas video. Okay, so that's it. Bye.